Thank you very much. I appreciate you've got a great crowd. I'm Greg Heibel. I'm a partner here in the Menlo Park office. I'm in the technology companies group, so I'm a startup guy. I'm a corporate lawyer, do typical startup financings, M&A, and occasionally get founders out of jail. That's only happened twice. We will never repeat those stories, but if you guys could turn around, because I'm told that on the other end of that camera, we have a group in our office in Tokyo who is joining. So if you can all turn around and wave, hello Tokyo.
Hello Tokyo.
Of course, we can't hear them. But again, thank you very much. This is a great topic, and we've got a really diverse crowd here in terms of backgrounds, and we have a very diverse panel. Some of you have been to my panels, which I do differently than most, because most panels that I go to, you hear too much from the moderator. You're not here to hear me, you're here to hear them. So we're gonna do it a little bit differently than the traditional style. They're going to introduce themselves, because they can do it better than I can. While they're doing that, if you guys could come up with a question that you would like me to use to guide the discussion, I'm going to write it up on the whiteboard. So we do a Q session, and the A's come later, and then at the end we'll do a formal Q&A. So if you guys can be thinking about it, because every once in a while we get a session. Sometimes I put a ringer in the crowd, and I don't have any ringers today to get it started. So I'm relying on you guys to somebody stand up and get it started. But we will start with the introductions. Start on that end.
So I'm Martin Hack, serial entrepreneur, investor, and advisor, mostly in the big data and AI space.
I'm Niousha, the founder and CEO at Brite Health. It's an AI platform for drug development.
Hello. I'm Zavain, an investor at Lux Capital. I teach AI at Stanford, and I help a few basketball teams on Moneyball and data strategy. Also on their shooting form.
My name is Forrest Iandola. I am the CEO at Deepscale, and we build perception systems for autonomous vehicles.
Hi, Sundeep Sanghavi. I'm CEO of DataRPM, third startup, still happily married, 2 kids. We're trying to teach machines how to do machine learning. So it's a whole another concept we'll talk about today.
Hi, I'm Lutz Finger. I'm running a data science team and a data engineering team at LinkedIn, as well as I'm teaching at Cornell and Harvard data science.
Go Big Red. So I hope you have the question. Those were quicker introductions than we usually let them tell you. I'm a
They gave us 6 seconds, and I think everybody kept to the line.
We do get paid by the word. You guys will all get your bill later. So who has a question? Because otherwise you have to listen to mine.
Can you hear me okay?
I can hear you fine.
All right, so if you have a lot of memory, what would you do? In this case, it's all coming up next.
Have a lot of memory, what would you do with it?
So it's slower than data.
Presumably on the computer, right? Like not in here.
You have it in your head. But yes, computers.
I see most of the AI focused on perception and put a lot of control or action.
By the way, fortunately, you don't have to read this. I'm going to present it.
So machine learning is all about correlation, but not about causation. How do you actually make sure that what you're getting from the data?
How do you deal with the situation when a startup promising company enters enterprise, we have a great idea, and we face this dilemma? Oh, we have already 50 PhDs in data science, almost candidates for Nobel Prize. How do you deal with this situation?
Sorry, who is you? Is it the enterprise or the startup?
Startup, yeah.
You saw something from the other end.
Yeah.
So how do you solve the NIH problem?
sounds very simple but very pervasive question. Why does 3 billion people still believe that God was a virgin? So, how to convert words into meanings?
Okay. I thought you were asking the question. With people.
Why can't AI or ML
Yeah.
help us do the analysis?
I was going to say we're going to have a different session. You may have to help me when I ask. I want to ask it the right way.
Follow up on that is how we can take on lawyers. From on-site, yes.
Make sure there are no lawyers involved. All the way in the back.
How do you define, what is cognitive computing in your view? And how is it different?
Sorry, it's
What is cognitive computing in your view, and how do you differentiate the machine learning area?
Processing powers that you're seeing across survey crews, what are some of the platforms you're seeing that are in use and that are most acceptable? This question might come later on. I talked to someone who said, I'm looking in the traditional machine learning space. Near the end, we talked a little bit about their prediction of where this is going.
like legacy AI.
In a world where we're hiring, training, and retaining data scientists and some finding really smart, where are people actually using machine learning in their day-to-day lives, or actually applying machine learning versus solving examples at large scale and they'll be used.
A few more.
Who owns ethics in prediction and recommendation?
Skynet.
So what are the basic minimum building blocks of a machine learning system? And what are the minimum requirements for something to be all machine learning is defined? What is your vision planning for human brain to machines hybrids? How can this complement the
What is your prediction for the emergence of AI as a service in some consumer brain?
How do you make use of your unlabeled sensor data?
Okay, I got the most important one, which will affect Silicon Valley more than anything. It's what's going to happen in the election. Will it be Donald Trump who can optimize information on a real-time basis instantaneously, or will it be Hillary Clinton who takes 3 days to make a decision on anything, needs to run it through a focus group?
I think we had that question about ethics, wasn't it?
No. It is. It's a Determine your future.
I'll let you take that one up with the panel after.
I'll see you in Canada.
We know a lot
I've lost
about
control of this room already.
Yeah, my question is, we know a lot about the consumer use cases of AI and machine learning. What are some of the enterprise or business or industrial use cases that you guys have seen?
All right, I think we've got a good set. We will do a normal Q&A at the end. And if I butcher your question, let me know. But I was actually going to kick it off with just the generic, to kind of help set a baseline of how the panelists are thinking about what is machine learning.
Well, machine learning is that a machine can be trained on past data to come up with predictions of the future.
Yeah, the only thing, let's see, I would have predicted that using machine learning. It's going to fail. But the only thing I would add to that is, training the models to predict the future by the machine. So there's supervised learning and unsupervised learning. So that's the two categories of ML that we're really getting into.
Yeah, and I think there's sometimes a misconception about, we have huge amounts of data, so therefore we can magically feed that to a machine learning system. So many of the success stories in machine learning still require some sort of human annotation on some of the training data to be useful. So infinite data isn't always the answer without human labels at this stage.
The one caveat I would have with training data is sometimes a false confusion that it's done beforehand and then kind of processed afterwards. Like, that's not always the case with the Hillary Trump example with potentially online learning or real-time processing of information. I'd classify it as anything where your algorithm or model has an open feature or parameter that's set at runtime or at training time.
What I would like to add is to get the data that is available from the past and also ongoing data that is coming as a stream, and refine the model in a continuous basis so you're always solving a problem in a better, more efficient way.
Yeah, so I would agree with everything that has been said here. I'd probably add that machine learning and AI is kind of starting to be used interchangeably, and AI is kind of becoming the umbrella definition for everything, multivariate statistics, predictions, reinforcement learning, deep learning, so it's kind of being slogged all in together. For me, the purest definition for me around machine learning is we're essentially letting the algorithms do the work that historically would have been done by a human, such as querying data and letting the algorithms provide us with the answers as well. So that's about it, yeah.
So is AI just taking over for big data as the current trendy?
Yeah, we probably reached the hype cycle there as well, in a way. I don't know what's after that, but
it's deep learning, yeah.
I guess in the press, a lot of different things can diverge from reality, but I think the reality here actually is that, big data is, okay, you have lots of data, you're doing something, it may be something pretty trivial, but the quantity of it is a challenge. With machine learning, so if you have a math equation or a way to go index into an array or something you can explicitly write down, you do not need machine learning to solve your problem. If you don't know the equation for your problem, machine learning may be a good tool.
Well, let me ask you, so does machine learning take over if you don't have somebody who can design the appropriate array? Is that a place to?
So like if the solution, if a hand-implementable solution exists, but it's a lot of work,
yeah.
I think it's a gray area, like it's worth a try.
There were actually a paper from statisticians who kind of like, the paper was titled, Big Data, dash, shouldn't it be us? And this whole paper went on of, like, I mean, mathematicians and statisticians have worked with data since ages. It's not that Silicon Valley has invented this, right? And we have used very little data. to come to conclusions with statistical methods. Now, the sad story for statisticians is they trained themselves so hard to use little data to come to conclusions, and it was always complicated. And then suddenly we had a lot of data, and machine learning people just run a lot of data through, find local maxima, and very often, like with a lot of data, you have a higher accuracy, despite the approach is way more dull than all those relatively arty tools from statisticians. And that kind of like then leads to it. However, the whole big data stuff, I mean, how many points do you need to describe a line? 2, right? Now, if somebody asks me, when you have more storage, well, you could store the same line and it was 1 million points, or 10 million, or even more. And then we call it big data, and we cash in venture capital, but it just doesn't make sense.
To add to that, you know, if you look at it from a science perspective, one of the big changes that's happening is in Industry 4.0. So there is a lot more data available today, and you know, why is AI sort of coming back? Is that in the 80s you were not processing. You didn't have the computing power, you didn't have the cloud, you didn't have the infrastructure. Storage was still expensive. But now today, with all that going away, you're able to process that data. And there's, I think it's like 40 exabyte of data we'll be creating by 2020. What are you going to do with that data? Right? So there's data everywhere. What are you going to do with it? So I think machine learning becomes an obvious choice. And well, let's just use ML to figure that out. Well, where's the hypothesis? Somebody earlier today in the conversation at the social hour asking, well, what is your hypothesis? What do you start out with? So I think a lot of companies that are saying, hey, we want to use ML. If they don't have the hypothesis on what they want to solve, it's just another technology.
So Zavain, as an investor, do you care about the difference between AI and ML, or is it just whatever they put on the deck?
To the extent that it shows like lack of critical thinking from the entrepreneurs, I care. If they're doing something fairly basic and calling it AI or deep learning, I kind of check that against their technical chops. But candidly, I don't care. It should work. It should be defensible. It should create value. Right? Beyond that, everything's fair game.
So one of the questions, Martin, one of the questions was, what are the building blocks for an ML system?
I would say, there's no industry standard at this point, but the 3 things that you want to have in mind as you kind of embark on doing data science and AI or machine learning, whether it's in-house or it's through some cloud service, there are 3 things that I would think are necessary. The first one is data preparation. That may or may not already be machine learning. You can certainly use machine learning to prepare data, but you definitely want to have your data preparation down, because reality is most of the data is not ready to be digested. It might be missing values or whatever else you can throw into data is usually out there. So prepare the data. Second, create and build the models. The model is essentially what historically was a query. So somebody wrote an SQL query to look at their database. Now the model becomes encapsulated in that, and I let the algorithm do the query. And the third portion is now deploy that model into production. If you have those 3 things, you have a pretty good chance of creating a production machine learning environment. You could skip the third part if you just want to do rudimentary analysis on discovery of data. But yeah, for most enterprise companies who are doing serious ML, they would have those 3 in place at a minimum.
Just to have fun here on the panel, Martin, how do you create models, right? So let's say you got the data preparation done, as you figured it out, but when you've got sensor data that's coming out of a turbine, a pump, a compressor, an engine, is it really feasible to let humans create these models?
Well, I think it's better than letting humans do SQL queries. So, it's a start for people who are, looking at real-time production level data. They will probably spend the time and the money and the resources of getting that up and running in a production environment. But you got to start somewhere with a baseline. There are certain industries that are just waking up to the fact, oh, there's this data science stuff, let's go ahead and start doing that. So for them, having a baseline approach, which I think was the question, what are the basic building blocks, would probably not be a bad idea. later on, I think, as it becomes, and now I'm answering another question on there, which was basically where do we go next? Machine learning today is kind of going towards giving us answers that we have never seen before, or maybe didn't even bother to ask. Now we're going towards optimization of data, and the holy grail of all of that is automation. Basically, how do we automate the hell out of essentially the algorithms, and to the point where we could have actually end up an algorithm creating another algorithm or code. That's, I think, is the holy grail of the entire world out there.
And because you can't have a drone or AI panel without asking, will that result in the end of the world?
Well,
When does Skynet come turning on?
We actually had a call last week or something where I think one of the jokes we had ongoing was how many minutes before someone mentions Skynet. So it's come up twice now, and I think it's 20 minutes in. So
I really should have put money on that.
Always take the under.
So I'm going to misquote this slightly, but I think it was Andrew Ng at Stanford who said that worrying about Skynet's a little bit like worrying about overpopulation on Mars.
So, Forrest, one of the other questions was there's a sense that AI is principally focused on perception as opposed to control or motion. Could you respond to that?
Sure. So I'm going to be speaking mostly from the automotive perspective on it. I mean, there are lots and lots of areas where the end goal is for some sort of agent to interact with the real world, and control is necessary for that, right? So whether it's a home robot or whatever makes sense. But from the automotive perspective, there is a lot of hype right now around training models that take pixels or LiDAR depth maps as input and produce modulation on the steering wheel torque or the gas and brake as output. And I haven't, I've talked to lots and lots of people in the automotive space who are building cars, some of whom are our customers. None of them seem to think that that's like the solution we should put in production tomorrow, but they're playing with it. I think the shorter term solutions mainly will be based on the perception system that outputs an environmental model of where all the other vehicles are, maybe velocities of them, other road users, where's the drivable space, like that being the perception module, and that gets fed to a separate motion planning system, and then it goes to control. That's sort of the current separation of church and state, but here's what I see the long term being. I see the long term being, okay, so we do have the rules of the road, so we should encode those somewhere. It'd be dumb not to, and that can be a piece of sort of the hand-designed, planning and control system. But as humans, we know there are lots of edge cases that aren't written down anywhere, and that you may have not really be able to think of a rule for. So I think you want two parallel systems in terms of automotive. You want one that's perception, motion planning, and control all kind of well understood. And when that system is saying, I have a low confidence score, I'm confused, it should then also tap the end-to-end train system that's got some edge cases covered. That's the way I would go about designing it, and that's what we're doing with our customer base. But there are lots of options. I think there may be markets where that kind of machine learning control policy is something that's practical sooner.
All of this took over once because it's not a fair question, but given what the scenario that you just described, how do you regulate that? And I mean that from a legal perspective. We've obviously seen in the news Tesla's issues, and there's so the regulators are getting involved, but it's kind of like the other question. They don't know how to design the array either. How should companies, if they're doing something new, how should companies be thinking about explaining what they're doing to people who are tasked with regulating that have no comprehension of what's actually happening?
So I think again, I'm being a little bit narrow and being automotive biased, so hopefully someone else can weigh in a different industry or different aspect. But at least in this world, I think there's kind of a sort of qualitative gap between there's a driver still in the loop and we're helping that driver versus we're going to replace the driver. So I think with the driver in the loop, the argument you always want to be making is, look, here's driver only, here's driver plus the aids that we're providing. And the driver plus aids should ideally always be safer. And there are UI questions and so forth that are a big piece of making that happen. So I think the lift on the driver's safety is what you want to be focused on, aiming to verify and user test and so forth. For more comprehensive autonomy, I think you also want the A/B comparison of human behavior versus car only. But I think having a human level baseline is the right thing to do. And then of course, like you could make an endless number of test cases. So I'm over time here, but let me just get one more point, which is, so like the IIHS and NHTSA, the U.S. Testing administration for crash tests, as well as Euro NCAP, they sort of let you overfit the training set, right? That you know exactly what the crash accidents will be, the crash tests will be. They now have crash tests for 15 and 25 mile an hour, accident avoidance. You know it's going to be that inflatable pedestrian, I believe it is. So like you just train for that. So I think there need to be like on the government side, it needs to be more like the SAT, right? Where you kind of know what kind of questions they're going to ask, but it's going to be a different one every year.
Solves for that problem is the lawyers, when it goes wrong and somebody is killed, there will be a lawsuit eventually coming. So
we need to do this in a different country where people have less lawsuits, maybe.
I think there's actually. So there's an industry that's already doing that in terms of regulation. That's the credit card industry. So if your credit card application gets denied, there has to be a reproducible step why that was denied. It can't just be some arbitrary algorithm, whatever came up with the denial. And that's regulated by the government, SEC. There's a bunch of authorities involved there. So if you want to apply for that, people are already doing that. So I think a similar approach can be taken in other industries, where essentially the industry as a whole and government comes together and say what are acceptable standards for essentially, which also goes to the ethical questions, what an algorithm can and cannot do actually. So there's industries already doing that today.
I think this touches on a few points. One about the ethics of machine learning. I was looking yesterday, there was a paper on coming out of, I think, Stanford titled Programmer is to Male as Homemaker is to Female. And it's, if anyone sort of were to, in fact, it's this like 2 or 3 year old paradigm for doing an LP, and this is kind of an analogy that the algorithm had found, and it was based on prior training data. So to the extent that prior training data, which is what you folks were talking about, kind of has expressed in it biases, oppressions, kind of injustices on different subpopulations, it will manifest in whatever models you train against that. And particularly for the credit industry, there's actually an example where like the #1 indicator for should someone get a loan is actually zip code, and the #1 kind of sub-indicator within zip code is race. Right, so there's like I think a famous ruling where that's actually not
both illegal, yeah.
They're both illegal now, right? So that's an interesting one. In terms of like another example that's analogous to the car example, the FDA, there's like a bunch of genetic data, and I certainly make a bunch of investments in the combination of kind of machine learning and genetics and computational pharma. And it's interesting that the FDA hasn't yet evolved a lot of like, and this goes to the causality and correlation question. I think a lot of the interesting like kind of philosophy behind machine learning right now is removing ourselves from this kind of assumption or bias that there even is such a thing as causality. I think that's philosophically sometimes undetermined and not really well defined. And so using kind of data to kind of look at input and output and being completely empirically driven is what a lot of computational pharma companies need to do. What's interesting is when they go through FDA trials, they need to kind of work backwards into the former language and look for a mechanism of action, even if it isn't accurate, but they need to be able to say, this is what we think it's doing, because people are still used to that particular vocabulary.
And from our perspective, I'll give you a practical side where we have customers like Jaguar, and then we have GE. In Jaguar, you're absolutely right, PI is big issue, driver side versus the mechanics, versus GE on the aviation side is completely different. So we're even seeing the legal involvement at these two different corporations, type of data, size of data, where it's coming from, who's originating it. There's a lot of legal involvement in that.
And we have a catch-22 situation, right? Because on one side, you're saying we should not think so much about causality and cause, or correlation and cause. On the other hand, we as well see skewed data will give skewed results. I've done one study with my Cornell team where I looked at the stop and frisk program in New York City. It used to be a very big outcry that this program is very racial unjust. So they removed from the code actually any features or any variables relating to race. Now, but the data which is used is actually racial unjust. And therefore the computer system is still trained racial unjust. And despite that removement, the data is actually even like the approach or the program has become even more racial and just today than it was before. Therefore, the cause and causation setup, right? And like if you would, no academia would go through and say, I just tested, right? I tested it before I find a correlation and then I publish a paper. I had no clue why I'm doing this. You wouldn't get through with, in a medical sense, right? Because we have seen a lot of people dying. I remember on the Harvard study about women taking estrogens, 200,000 people died, women died, right? Because they didn't think through what it would mean. They had lurking variables, which they didn't analyze. And that is a little bit the risk.
You come from the healthcare side. How do you guys think about the data that, what to do with the data that results from the platform? How do you think about it differently than, say, automotive?
Yeah, so one of the most interesting actually concepts in healthcare is how to anonymize data and use the data in a way that, first of all, the concept that the data is actually owned by the, by the users, not by the healthcare system, and also how to use the data in order to not only not scare people in terms of any prediction of the disorders or any prevention of the disorders, but also being informative to them so that they can actually take use of their own data and really take action. Going back to that action question, how we can be actionable on the data actually. So what actually is important in healthcare is to use anonymized data to understand what's going on in the data and use a prediction model to identify the populations who are at risk for some disorders and then giving them preventive strategies. The approach to understanding who's at risk and the approach to giving them, reporting them that they're actually at risk for some disorders, it is a very subtle problem, and it has to be done in a way that it's not scary to the population, it is actually very informative to them, and they can actually take action based on the data. So it's a very important question. It's very, very hard question to answer actually. But we have to find a solution for that by using the data.
So we were talking earlier about the question. If you're dealing with consumers, should the consumer know that underneath in whatever the process is, that there's AI or machine learning, or should they be thinking that no, there are a bunch of really smart people that are putting this together? Philosophically, how much should we be communicating? How much should companies be communicating to the users that this is really just a bunch of very complicated algorithms that are giving them what they've asked for?
Let's construct for a moment a very shitty user experience. So you go home and you want to watch a movie, right? What are you switching on? Netflix. But instead of the movie recommendation page, you get a bunch of tables which tell you the most likelihood that you will enjoy this video because of the word cloud of how this video was described in IMDb and the likelihood that your neighbor has seen a similar video. I mean, I just want to watch a video. So the answer is pretty much anything should enable something. And this is pretty much the question. I published a book which is called Ask, Measure, Learn. And the problem in today's world, I mean, you don't need to read the book. It's actually, that's what it is. Ask, measure, learn, right? That's it. 65,000 words. So,
right.
But the problem is in our today's world, we do measure because we can. We never ask and we never learn. And with that, we don't get any product out. So when we talk about this building blocks, and Martin's 3 building blocks are absolutely technically correct. But I actually would say, before we start building a machine learning setup, we should actually figure out what do we want to do? What is the question we want to solve? And I'm talking to a lot of industries where people say, wow, LinkedIn is built out of data, which we are very data-driven, which we are. How do we get there? And then they come normally with a bunch of recommendations what databases to build and what machine learning programs to get, but they have no clue what to use it for. It is like Netflix not thinking about the value they can bring. Therefore, we as a consumer should not care. We as citizens, that's the ethic question, we as citizens should understand what it is, but we get to this later once we answer the Donald Trump question.
Yes, add to this, asking, Siri, right? Do you really want to understand Siri, or do you just want to ask questions to Siri?
Martin, one of the questions was, If you had a lot of memory, what would you do with it?
Well, use it. There's no shortage of making use for whether it's distributed or a single system. Fortunately, the software, the algorithms now are smart enough and computationally efficient enough to make use of that. That wasn't always the case, 10, 15 years ago. Even if you had a really fast algorithm, it probably wouldn't have helped you because the hardware just wasn't ready for it. So now if you have a lot of memory, you could now think about a always on kind of a learning system that continuously learns with new data points coming in. So the historical, or even today, most machine learning systems are, if a training set that gets tested against a live set, and now I put it in production. That's pretty much what most people are still doing out there. Some of it is because of computational aspects, some of it is just, that's how people have been doing it for a long time. So now if I have essentially unlimited memory, I could have a system that continues to stream data in, and it gets bigger and bigger over time, but it also becomes smarter over time. So every new data point becomes a new output, essentially, and it immediately uses it to learn in the machine learning sense. So that'll be one approach that comes to mind, and yeah, it would still be expensive, but if, again, to Lutz's earlier point, if it justifies the outcome, that let's say it's predicting the stock market, it's predicting if somebody's going to buy or not, predicting real-time situations, it might be justified. If you're just trying to do something rudimentary, you can still do good old batch processing. Nobody's going to care about that. But if essentially real-time decision-making is at stake, then it might very well do it.
So you call it the edge, you call it the fog, whatever you want to call it, whatever the analytics, new buzzword is around that. But going back to what Martin's saying, real-time, in-streaming. So if you look at some of the clients like GE Aviation, I would like to know if that engine's going to fail before I get on that flight. I'll take the in-memory, no matter what the cost is, to process it.
As I joined LinkedIn, one of my dreams, actually, and one of my first projects became that I wanted to predict a career path out, right? Each of you, as you're sitting here, you have like certain training, certain educational background, you're living in a certain area, went to certain schools. And we feel very much as an individual, but the whole story about data is obviously it's a collective and not you as an individual. So we are over 400 million people. There are 400 million members in LinkedIn. There are people like you. And what have they done 5 years after your current timeline, right? Can we predict this? And then we come to what is called big data, because yes, we as human beings are very individual. So if you have a network which are, let's say, maybe 10 million members, you wouldn't be able to predict anything except that a lawyer stays a lawyer or something like that, right? You wouldn't be able to completely predict the beauty of career development. No, I'm getting beaten up later on. No, but if you have a lot of members, then obviously can do this. So that's where the big data effect comes in. As soon as you want to build out a more fine-grained picture of something.
Well, I'll be the lone dissenter on this. So these are all good points. While everyone else is drunk on large quantities of slow memory, what I see is, yeah, I slipped it in there, didn't I? What I see is, Intel, despite Moore's law more or less ending, is still making processors more or less twice as fast every 18 months. So the processor's going like this, memory is going like this, network is going like this. So for distributed large-scale data center applications, what's actually killing us, Intel and people in that vein are doing such a great job with speeding up CPUs that the memory and the network bandwidth are the limiting factor, and that's worse every year. So I would much rather have the appropriate, well-balanced memory hierarchy that serves the processing elements well, versus just large quantities of sort of undirected slow memory.
Zavain, one of the questions was.
I also have thoughts on data center.
Go for it.
I'm kidding.
But one of the questions was time frame for AI as a service. Are you seeing that?
I think so. I mean, I think it's it's online. I'm an investor in a company, not to toot my own horn, clarify, that has deep neural nets for computer vision. I know Google recently released a bunch of frameworks for NLP. There's certainly TensorFlow, which maybe a lot of you guys have heard about. None of these things are new. R existed, SciPy existed back when I was in grad school. Like these have been approximations towards ML as a service, if not AI as a service. The question is, when will it truly be one size fits all, and when will a company like LinkedIn no longer need PhDs in-house, but rather be able to use some cloud, whatever, from Google or LinkedIn or whoever, clarify maybe. Seriously. I don't know when that's going to happen. I suspect it's going to happen sooner than we see it happening, and that's based on my kind of reading and knowledge and conversations with folks at really the edge and frontier of the deep learning space. Whether it's going to be deep learning that captures that entire scene, or whether it's going to be a whole bunch of different modalities of machine learning, who knows? But I think it's an apt question, and certainly if you're an investor looking to make a big bet right now that's bold and audacious, it would be trying to find the right team that's going to capture that particular kind of horizontal.
AI, there is a lot of saying that AI will never exist because as soon as we have built it, it's not artificial anymore, right? We talked early on about the different ways. A check computer, a check program, uses heuristics, uses database, it uses a trained approach of rule-based settings. Is that now AI? Well, let that same computer program implement it in the car and it will lose, right? It won't drive a meter. Sorry, I'm European. Don't drive a feet. So you have created machines for a certain specific setup. And those machines enable us as human beings more and more. Is that AI? I have my, we tend to think about AI in terms of Arnold Schwarzenegger. I think that's a lot of hype and it helps us to raise venture capital. But I'm not sure whether we really are out in this kind of setting.
We define, I'll switch it from AI service to machine learning as a service, that seems a little bit more bounded. But we defined machine learning at the beginning of this. I think collectively, if I were to repeat it back to you, it's, one of the core things here is machine learning is learning things that are hard to program, having the computer learn things that are hard to program manually, right? So that's kind of like asking, is there going to be programming as a service? Well, sure, there are APIs to databases and things, right? And Clarify has a great platform for if you want to build image classifiers and import your own images. That works awesome. And they may have some long-term play for universal machine learning as a service. But there are so many individual niches that even let's say if they're all deep neural net based, or they're all support vector machine based, those are building blocks, not systems. So you still, if you're doing the learning side of machine learning, you still need a fairly comprehensive system that may be domain specific. So it's really hard to find that horizontal, I think. We've looked.
And I think it'll take time. You look at the early days of relational databases before Oracle came around, folks were writing their own relational databases, right? And it took a while for someone to really figure out the correct homogeneous platform with the right APIs and the right hooks that scaled well. Certainly this was a critique of AWS early on, right? It's why in the early, late 90s, folks had their own servers and set up their own kind of computers for their websites. It's why Series A was 15 million just to get a website online, right? These things take time. What is interesting to note, again, as I mentioned, particularly for a lot of the old school pre-deep learning APIs and cloud services for machine learning, none of those were big companies, right? MATLAB's not a great venture bet. R, Python, most of that stuff is open source. So I'm sitting here making these bets and I candidly can't tell you if it'll be big or not. We can point to something like a GitHub, which is code hosting as a service, or Oracle, which is relational databases as a service, or Hadoop, which is also commoditizing with Cloudera and Hortonworks. But it's just kind of, you look at the past and you try to predict the future that way, I think.
Yeah, I think also we kind of have to differentiate between, is it applied AI or what people call a general AI, as in a self-aware AI system. I think we're still ways away from that. But applied AI, absolutely, it's happening out there. Yeah, I would argue Siri, that's NLP plus AI. If you look at things like Amazon product recommendation, that's AI. So as a pointed and applied vehicle, yes, it's out there, and we're going to see a ton of that happening over the next few years. Startups and big companies are going to jump into that. But a general AI, I think we're still ways away from that.
I also believe that the applied AI is going to be customized this decade. Actually, it has to be customized for each industry for the next several years, and therefore, in this decade that we're in, we will need PhDs in companies to really take care of those modules and specify them for any application that is being developed.
To challenge that a little bit, we're working on a project with GE, Cisco, and Jaguar combined together now. 3 companies are combined together to do the process called meta learning. It's been around in the research field for about a decade now, and it's really how do you teach machines to do machine learning as a services layer. So I think there's a case for a very cross-industrial applications for AI, and it's definitely taken hold.
I actually think the discussion in terms of AI and what kind of machine learning program, is it a regression, linear, is it like a model? And we need a PhD to actually understand that. That's not needed in the industry. What is needed is to have the right data set. Like first have the right question to make like impact, as we discussed earlier, but then have the right data set. Because without the right training set, you will never train a car, no matter how intelligent your training tool behind is. And actually, I had, before I joined LinkedIn, I had founded my own company. We had good growth, it all went well. But then at one point I realized that actually the data which I used to deliver the service and create value was not protected. So anybody who figured out what I had figured out could actually make the same thing and just cut me in price. And that started to happen, therefore I sold out the company. Kind of like put the word AI and big data on and got 25% more for it. Was nice. But the point is, data is the essential part in this. It is not the model behind it. If like people are saying, well, like with data you dig for gold. If you dig for gold, you're not looking for small nuggets, you look for something for real. And very often is, if you don't have the data, then it won't go anywhere.
Not only if you don't have the data, but are you the only one with the data? That's what you experienced, right?
Yes. Well, I mean, like, yes, absolutely. So, like, if you have the data, you're actually protecting the data is one of the topics. Like, once you have data, how do you protect it? How do you keep that asset?
Differentiate data sets, right?
I think one way to protect the data is to collect time series of data so that it takes time for other companies to get to the point that you are at in the collection of the data that you have.
Now, Google is a perfect example, right? I mean, they had the same data as Alta Vista. Anybody still knows that company? Right? And it wasn't... I'm your age. So, but it was the same data set. Alta Vista could have built up this data set, they didn't. And then afterwards, it was a competitive advantage. Google build onto it very smartly.
In the Google case, I think you also see, you can riff on this all day. In the Google case, you also see how software is transient, right? Like the same software that Google had in 1998 and in 2008 and in 2014 is wildly different than the software they have today. But what's stuck is this clickstream data, right? When someone searches dog and they click on the third example, Google and only Google learns to upweight that third link for the next time someone searches for dog, right? And that's how they kind of maintain that competitive advantage. Ask Jeeves is actually still my home site, so.
The weird thing is, that is the second time this week I've heard a reference to Ask Jeeves. I don't know what's going on.
I'm back.
Forrest, one of the questions was the non-inventive year problem, and for a young company selling into a large, technically sophisticated organization, how do you convince them to kind of do the build versus buy assessment in your favor?
We just kept going to different industries until we found one who had a problem they didn't know how to build a solution for. So they call us now. I mean, we get cold emails from people in the auto industry and automotive supply chain every week without doing any advertising, because they keep allocating, billions or tens of billions of dollars to try to build increasingly autonomous vehicles that will make them relevant as that emerges, and they want to be the last one to market. And so allocating all that money doesn't make people just materialize who have those solutions. And so they don't have the luxury of being like, well, your team's still a little small, so they're like, it's us or nothing in some cases.
From a unique advantage perspective, again, being my third startup, having spent money on marketing, try to go across horizontal space and try to get to every vertical possible you can't. You gotta find your beachhead, you gotta find your domain expertise that you really wanna go after. You know, it doesn't matter how big or small the vertical is, as long as your solution is solid, right, you'll find your beachhead. But if you try to go horizontal, and I'm sure the investors will love to hear that, right? Once you find that beachhead, you will see the effect of other industries coming at you as well.
And it may not take very long for you to be like the established player. I mean, finding the beachhead of something that people need and nobody else has as a way of ramping up quickly.
In the land of the blind. Niousha, one question for you, the brain to ML interface. I know that's not strictly yours, but I'll throw it your way anyway. Where do you see the human interface going more broadly with ML AI?
I can speak of healthcare more than other industries. I do believe that one area that the brain is not really responsive, the human brain is not really responsive, but ML and AI is actually making some good decisions is the diagnostics. Understanding who has to be diagnosed with a certain disorder and how is the treatment should be going on should be actually related to some data that has been collected in the past. For example, if we go back to the precision medicine and the precision drug development, what drug is going to has the best effect on a specific person? That is a very good question that we can ask from drug companies or from the physicians that they're prescribing the drug. In the past, when a physician wants to prescribe a drug, they prescribe one drug, they see the effect, they wait for 1 month, for example, then they change it to another drug to see what is the effect of the other drug, if there's any side effect on that person, because of the genomics, because of the lifestyle of that person, because of the model of the body of that person, how is the drug effective on that person is a big question for physicians. But AI and specifically machine learning can actually be used for replacing this decision making at this point. We can use the data from the genomics, from the the drug effects on human being, from using lifestyle and habits of the people in order to understand what is the best drug to prescribe at what specific time of the duration of the disorder. So this is one main question that I do believe that is going to be answered in this decade using the specific data that can be collected. It is really possible to collect all of this data that is needed and really try to help human beings on that, which I don't believe that human brain is actually able to answer this question.
Yeah, I'm still trying to figure out, when my wife is mad at me, it's never the last thing I did. It's probably a series of things that I did about 12 months ago, right? Machines, fortunately, we're trying to, do that on the ML side with the machines. They're leaving jobs. They're, signaling throughout their life cycle on how they're going to die. So when I look at the, fact that 6 million devices, sensors, machines, whatever you want to call them, that are getting connected every single day, and if you could predict the failure, whether that saves lives or helps Tesla increase their stock value, right? If anybody wants to check out on how AI or ML is going to change, especially in the world of connected cars, just go check out the Gigafactory by Tesla, and you'll see how many sensors are throughout the factory. From the minute you enter the parking lot, you enter into the door, you go to the factory, you go to the assembly lines, everything from temperature, sensor, your vibration, floor vibration, everything is getting connected, right? And if you could predict the failures of these machines prior to it happening, that's a huge service ML could do.
A question for you. Somebody had asked about how to make use of unlabeled sensor data. And that's not, obviously sensor data is not your area, but I assume that given your data sets that you're working with, it's not all clearly labeled data.
No, it's not. But the question is always why you want to do this. No, when I'm looking from a LinkedIn perspective, like our vision is to create economic opportunity. This is not very broad, right? So now we're breaking it down and trying to figure out what are good signals, for example, for somebody to suggest the right job. And then you break it down further, you realize it's actually not the job which counts, it's the skills which each person lists which counts. And then you build a model on top of this. Already here you have what is like unlabeled data, because skills you can, if you go onto LinkedIn, you can create any skill. You can be left side panel talker skill. I can put this up, right? And you can endorse me for that, or or go home and like say that I have the left side panel talker skill, right? Now that's obviously a silly skill, and not many people will have registered it, but maybe it's a very rare and maybe an upcoming skill. So it is an unlabeled piece of data. And we need to figure out how to work with it. And what we use is we use crowdsourced intelligence. We see whether more people are classifying them as left side panel talker. And if that's the case, then there seems to be a value. And if these guys are all in the tech industry at a data science job, then it seems to be something valuable. So you need to work actually in those circles that you're trying to label stuff by the use of the data. But it's not always easy. Like the example which I'm over time, like one fun fact. The example I always bring in class is that I'm letting the class predict the weather in one city, New York, whatsoever, based on a Twitter stream, because everybody is excited about social media data anyhow, right? So let's do this. And you can build a model to actually, with a pretty good statistical relevance, predict the weather in New York at this moment. You train a classifier, you use NLP, all fancy stuff. Well, the smart guy actually looks at labeled data, the weather channel. They tell you this with one click.
There's 200 billion sensors that'll be connected by 2020. So if we can't figure out now how to predict based on what the patterns they're saying, we're going to be in trouble. So I think a lot of the ML AI stuff that is going on right now is understanding, even if they're unlabeled, understanding what the anomaly detection is, what the segmentation is, what the influencing factors are from that data to make some sense out of it. And this is where the human cognitive brain and the domain is so critical.
Just to quickly play devil's advocate, because I get this a lot. This kind of like false panic of 200 billion, trillion, whatever number of sensors that will be connected in the IoT, industrial, whatever cloud. There's no, until there's proof that they create value, it's a pure hypothesis that there is value in that data. So like, while I agree that we should be instrumenting things, tracking data, the more memory, the more we can store, whatever, to assume that there's value, I think in the venture community we call it boiling the ocean, where you're creating a little bit of value for a lot of constituent stakeholders, but not enough to get anyone to really care.
Good example, like you all use Waze, right? And the question is, how many Waze devices do you actually need up on the ground to create value? Well, you need pretty much one guy stuck in traffic, that's enough, right? You do not need all those cars to be connected to say there's a traffic jam, 2 points for a line. So now there are other things, human behavior, and LinkedIn is more like obviously exposed to this, which is a little bit more complicated than a traffic jam. Then you might. But to build a factory and putting all sensors in it for a question you never had before, because it might help, is just using shareholder money to distribute it over the sensor guys.
Unless you're trying to predict when the machine's going to fail. So if you've got a hypothesis.
Hold on, like if you have sufficient data to predict the machine to fail at the moment because the machine gives you a log, for example. Now the very fact that there is a sensor sensing your temperature to a certain, like to the tenth of the digit degree, it maybe this helps, maybe it doesn't. As long as you haven't tested it out, it's probably not useful.
So I think going back to the unlabeled data, that's what you're going to have to find out. It is anomaly detection from that perspective, right?
So unless one of you wants to take the Trump question, I'll go to the audience for Q&A.
Is there an Orrick office in China? And the other question, sort of following on that, is there really East versus West different mentality about approaching these problems?
So I can answer the first question, yes. Beijing, Shanghai, Hong Kong, and depending upon how you want to classify Taipei. Is there an East-West? We'll open it up.
I'll go for a narrow example of that. So for Autonomous cars, so China, I've understood that China has an area of Beijing that you can only drive autonomous cars in, and that's something that, I mean, the Chinese government has a lot of pull over what happens in some dimensions of society that in the US we don't really have. So I think each country, especially for things that are as sort of safety sensitive as autonomous cars, each country brings something special to the table in terms of an opportunity, and we definitely shouldn't be just thinking US only or anything like that.
So I have a question about, let's say we have government and government has a lot of data, right? Governments naturally collect a lots and lots of public data. And assuming that some company being given access to that data and they come up with some insights, right? They extract some value and they even publish it online and make it like public. However, that company trained their models out of the data, and my question is, in your opinion, who owns the models that the company gained from the data?
Well, I mean, if it's government data, it should be the taxpayer who owns the money, owns the data, quite frankly. The question is if it's classified data or sensitive data. There's a bunch of companies who do marketing targeting based on government data, and to my understanding, the models and the algorithms might be proprietary, but the data is essentially still government, or in that case, part of whatever arrangement they had. They might do an open source thing where it's public domain data. Then it's kind of like if you do a FOIA for information request, then it becomes public. So you kind of have to classify what kind of data. If it's out in the public domain, it's public domain. The question is, if you then use it for commercial purposes, what happens next? Essentially, it's almost like an open source kind of question, and also resolve to that. But usually, and that comes down to who is using it. For example, in the cloud, if you have a license agreement where it's unclear and you service a customer, it might actually be that the customer ends up owning your solution. So as a startup, you have to be super careful, or any company, who actually owns the technology, specifically the algorithm and the data behind it.
So if you're predicting government behavior, I'm sorry.
I would like to turn it around. When we say data is an asset, right, then it is actually a service to the public good to bring this asset to a wider range. Like one of the things we did at LinkedIn is where we created the Economic Graph Challenge, where we actually invited universities to use a set data set, which is not behavioral data, but like anonymized data, which we have in a safe area, to work on it. So that is in order to fulfill the idea of creating economic opportunity. Now the question, if they come up with something great, well then this is a service for the public good, right? We're trying to create new things, and because we might not have a question correctly set, we said the question is the most important thing in the beginning, by outsourcing it, by putting it out there, we stimulate others to actually work with that data. So there is an element of public service and public good, which is actually awesome, and we shouldn't put too many lawyers on it.
If you're trying to predict government behavior in the future, the best thing to do is look for what they've been doing for the last 20 years, and it will probably look like that. So if it's somehow defense related, they're going to grab it, I would predict. If it is somehow health related, then more likely to make it broadly available, it would be my prediction.
Can ML help give proofs and also create questions? The first part of your thesis.
Well, I would say you don't need ML, right? You know those games where you kind of just shake something and then a magic 8-ball, and then you get a couple of questions. It's a lot of fun to play, especially when you're drunk. ML can create stuff. There's lately there was this guy who trained the computer to watch Blade Runner, and then the computer replayed Blade Runner. It was explaining Blade Runner, what he has seen, and so it recreated Blade Runner. Now obviously ML can learn interesting questions and then come up with a lot of interesting questions. Whether they're useful That is what we then call domain knowledge.
One of the main questions that ML actually can ask in healthcare is when you put a bunch of features or variables into a model, and then the model come up with the most significant variables which are predictive of some some disorder, for example. And if one of the features that is coming up is not something that you have hypothesized about that, then that is a great question to ask. What is the biological reasoning behind that this one is significant and not and you didn't think so, like the scientists or the physicians didn't think so. So I think the ML can be a great help actually to understand the underlying mechanisms behind human body, as well as by asking questions and bringing up features that we have never thought of them as being predictive or being correlated with disorders.
So just one quick comment on the regulation for autonomous cars. The industry that's most concerned about it is the insurance industry, and they're real worried about premiums going down significantly. So they've already studied that. But to a more relevant question, could each of you talk about deep learning applications that you've seen that are the most complex and useful in your experience?
I'll take the first one just so we can get to the last couple of questions. Who wants to grab that?
All right, grab the first one.
This is about deep learning applications that are interesting, regardless of complexity, or that have to be complex. Regardless of complexity, I think anywhere where there's like a high dimensional space that's difficult for humans to intuit features upon, and that's why something like perception with images or video or audio or self-driving cars, right? Computational pharma mapping genotypes to phenotypes of cell structure based on rare diseases. Industrial IoT and looking for mean time to failure for CapEx in big factories. I think there are examples. It's difficult to exactly know how to build a startup in these ecosystems, but those are three that come to mind, and that I candidly just stole from two of the guys right here.
So I think of four common types of data, so let's say video, images, audio, and I'll say everything that's not one of those kind of is almost text, right? So like of those types of things, deep neural nets have had the biggest impact in terms of 3x improvements in accuracy, not 3%, but 3 times improvements in accuracy or more on the images and video more often than anything else, which is partially because before this we were so bad at it. Whereas with text and so forth, reasonable heuristics tend to often be pretty good. To your application question, that's of course near and dear to my heart. So starting from being a person who spent years, did a PhD in Berkeley, mostly in computer vision and related areas, I spent 5 years, not just doing the research, but figuring out what this is good for. And we conversion automotive, but we see lots of opportunities in. I think that the number 2 application I would say for me, if I were going to go up another 24 hours a day, would be surveillance and security. There's just every IP camera is an opportunity to create value and make in terms of what exactly that value is, avoiding theft, understanding patterns in terms of retail people, and then sending that to investors. You can use your imagination. Those niches definitely exist.
I want to add where actually the patterns are continuously changing. For example, human bodies, one source that is continuously evolving, and you will need to really learn the machine over the new data then and the new mechanisms of the body.
If you could all please join me in thanking our panelists. And thank you for the questions. It makes my job much easier, and we look forward to seeing you at the next session.